Let's now look at how to display the values in the two-dimensional array. And because it's two-dimensional, I want to display the values in tabular form like this. So I've got row 1, row 2, row 3, and 4, and I've got column 1, column 2, and column 3. How will I display my values in this tabular form? We know that using a nested loop, that will take us to, it will generate the positions for each cell in the array. So to get this tabular form, we create a string. We join the values into the string. We join up the values of the first row. And as we're joining up the value of the first row, or accumulating, I should say, we accumulate the values of the first row. I'm separating them with a tab space, which is a #9. However, when I reach the end of that row, the cursor then needs to go to the next line, and then we need to bring in a #13 in our string. But they have to be brought in at strategic points in our loop so that we can then get this tabular form. So how is that done? We create the string that's set to nothing, null. We start our first for loop, R1 to 4, because I've got 4 rows. C refers to our columns from 1 to 3, and we are accumulating. We are accumulating the value in our array at position RC. As C changes, you are going, and row is remaining fixed. You are going to 1, 1, 1, 2, 1, 3, and it is accumulating those 3 values. When that loop finishes, we then go to our string and we add a #13 and take the cursor to the next line so that when I go back up, R becomes 2. I'm starting with the second row, but the second row is being accumulated on a new line because of the previous #13 that we had. So when this loop continues with R2 and C goes 1, 2, 3, we're going to go 2, 1, 2, 2, 2, 3. That's going to be accumulated with tab spaces. When that finishes off, we then go and add in a #13, which takes the cursor to a new line. So these nested loops continue. And at the end, when I'm finished with both the nested loops, I simply display the value of str, which is this entire array in tabular form. So that's how you display a two-dimensional array in tabular form. If we want to find the sum and the average, immediately, if I'm working with a two-dimensional array, here are my nested loops, and create an accumulator. Sum is initially set to 0. Create an accumulator that accumulates the array. The loops ensure that I go to each value in the array at each position that I've explained earlier. Those values are accumulated, and at the end, I've got the total sum. Once I've got the total sum, I take that sum and divide it by 12 because I've got 4 times 3, 12 cells, 12 values, and that gives me the average, which I then print. I print the sum and I display the average to 2 decimal places. Let's now look at the next technique. To get the next technique, I am looking at how do I determine the total number of even numbers and odd numbers in my two-dimensional array. So my for loop takes me to each cell in the array, and inside I check. How do I check for even numbers? If mod 2 equals 0. That is the value I'm checking inside of the array. If that value mod 2 equals 0, I increment my counter. And outside, when the loop's finished, this is where the loops finish. When those loops are finished, I display count, which counts the number of even numbers. How do I find highest and lowest? The technique is the same as we did in a one-dimensional array. We have a variable called high. We set it to the first cell. In this case, it's 1, 1. That's the first cell. My nested for loop that takes me to each cell in the array. I then check if the value is greater than high. And if it's greater than high, I take that value and I store it in my variable high. Similarly with low, I check if it is less than low. If it is less than low, I take the value and I store it in a variable called low. And you have to understand that because I've got the nested loop automatically takes me to each cell in the array. So when I refer to ARR2D R, C, that is the number in each cell of my array. And the loops take me to the different positions in the array. And then outside of the loop, I display the highest and I display the lowest. The final, well, not the final technique, but the other technique we need to know is how to do a search. Remember that when you think of a search, the Boolean variable should come to mind. So I'm searching for a value. So input the value that we are searching for. And I've got my array, my two-dimensional array with 4 rows and 3 columns. My nested loops take me to each cell in the array. And I'm looking for a match. I check if my value in the array is equal to the number. And if it's equal to the number, it means I found the number. But where did I find the number? At what position did I find the number? So the position is my R value and my C value, which is cut out here, and it should be int to string, and we should be displaying the C value. So a message is saying the number was found at row, and we display the R value in my loop, and at column C, which is the C value. So your R and your C tell you the row and the column where the number was found. In this case, your row would have been 2, and your column happens to be 2 as well. And then to determine whether it was not found, that's when we introduce the flag. We set flag to false, flag is Boolean. And then when we do find what we're looking for, we set flag to true. And what's missing in the code is here. When the nested for loop finishes, you now need to check if flag remained false, then it means that this condition was never true, hence the number was not found. And then you can display either in a show message that number was not found. And if the number was found, this condition would have been true and the value of flag would have changed to true, and hence this becomes false and it does not display this message. So this is a standard technique that we use whenever we're searching, whether it's a one-dimensional array or a two-dimensional array. The only difference is with a two-dimensional array, we're working with 2 loops. The final technique is a sort. How do we go about sorting a two-dimensional array? It's a standard technique we use. Instead of 2 for loops, now we need to introduce 4 for loops. The first 2 loops, I runs from 1 to 4 and j runs from 1 to 3. The second set of loops, k runs from 1 to 4 and l runs from 1 to 3. So there's four for loops going on, and we are checking if position ij is greater than position kl. And if position ij is greater than position kl, then we swap the two values, making use of our temporary container. And once these four for loops finish executing, the two-dimensional array will be sorted. You can try it out to see exactly how it works, making use of four for loops. These are all the basic techniques that you need to know with two-dimensional arrays. I hope this